So we got another equation. This kind of looks like the first one that I did, but it's a little bit different. So it says the equation of the line is y minus 3x plus 5 equals 0. For L1, find the x-intercept and the gradient. Okay, I like to get the gradient first whenever I'm doing this stuff, and to get gradient, remember, it needs to be in y equals form. So I'm going to move the 3x and the 5 to their side. Nope, not plus 5. So I'm going to get y equals 3x minus 5. The gradient is the number in front of the x value. That's going to be a 3. So the gradient is 3. The x-intercept is what happens when the y coordinate is 0. So 0 equals 3x minus 5. Add 5. So 5 equals 3x. Divide by 3. I'm going to leave it as a fraction. X equals 5 thirds. That means my x-intercept is 5 thirds, 0. All right, 5 thirds, 0. So now I get into the stuff that's more about the lines. So it says a second line L2 intersects the y-axis at 0, 2 and is parallel to L1. All right, a whole bunch of stuff going on there. So let's talk about what has to happen here. Parallel, same slope. All right, so number 1, same slope, 3. Number 2, it goes to the point 0, 2. All right, so it goes to the point 0, 2. So again, if you recognize right away that that's going to go into y equals mx plus c form, great, do it. If you don't, then we have to do this right here. So we're going to go y minus y1 equals m times x minus x1. That's the gradient, point gradient formula. That's y minus 2 equals x minus 0 is x, so 3x plus 2 plus 2. Y equals 3x plus 2. Okay, so there's that. Then we got this third part. Okay, the third part says a third line happens and it's perpendicular to L1. All right, so perpendicular to L1 and it passes through 3, 1. What's the gradient? Find the equation, giving it in that standard form, ax plus by plus d. Perpendicular means take the slope, flip it over. So it's currently 3, which is 3 over 1. Which means the perpendicular slope is flip it and make it negative. So there's the slope. That answers part C. Then I need a point that it goes through. Well, it says it goes through Q, so 3, 1. And then it wants the equation. So I do the same thing I've been doing for the rest of these. So y minus y1, y minus 1, negative 1/3 times x minus x1. Okay, now this all needs to be equal to 0. So let's go ahead and take a look at this here. So y minus 1 equals negative 1/3 x, and then negative 1 times negative 3 is positive 1. All right, it's positive 1. So I want everything on the same side so it's equal to 0. And I want the x to be positive if at all possible. So I'm going to go ahead and I'm going to move the x and this because I want the x to remain positive. So I get 1/3 x is positive. Y is also positive, so plus y. And then minus 1 is minus 2. Now, that was good enough before, but these are all supposed to be integers, which means no fractions, no decimals, nothing like that. The good news is that if you leave them in terms of fractions, whatever the bottom of the fraction is, all right, and if there's two different ones, whatever the bottom of the larger number at the bottom, if you multiply the whole thing by that, it should ditch your fractions super easy. Okay, and technically I need to do that too. 3 times 1/3 is 1, so it's going to be x plus 3y minus 6 equals 0. And that's my thing in that's my standard form right there. Okay, so the standard form can be a little messy. You just have to be careful and be patient, I think, and just go a little slower. These questions, when you see them, they're long. All right, they should take some time to go through and do everything. Make it organized enough so that somebody can follow along with it. Okay, I don't like how everything's packed together. So I would draw arrows like that, or maybe just kind of label what I'm doing with letters would probably be a better plan. I probably would not do that. But just make sure that it's understandable so that someone can follow along with it.